Hello and welcome to Skill Techathon. So today we are going to look into recursive CTE in SQL with complete explanation with practicals. So our agenda is in this video we are going to cover what is recursive CTE, key components of a recursive CTE, how recursive CTE works, key features of recursive CTE. Then we are going to look into practical applications with 3 questions. Then we are going to look into use cases of recursive CTE as well as the advantages of using recursive CTE. So let's start. What is a recursive CTE? So CTE stands for common table expression. And a recursive common table expression in SQL is a query structure that enables repeated execution of a query segment to generate a sequence of results starting from the initial result, which is the anchor part. The recursive CTEs are especially useful for tasks involving hierarchical data, iterative computations, or creating sequential data sets like numbers or dates. Now, the key components of a recursive CTE. So a recursive CTE consists of 2 parts. First one is the anchor part. Second one is the recursive query. So a recursive CTE starts with recursive. So we need to give the CTE name and the columns as. So this first part before union all is the anchor part. This will be the anchor query. It will define the base result set. And it is the starting point of the recursion. Now after union L, what we are going to write is the recursive query. So this query will reference the CTE itself and also will define how the next level of data is derived. So it will repeatedly execute until the termination condition is met. Now, after that, we are going to write the final query from the CTE. So whatever we want. So we are going to do this practically. It will be more understandable there. So here we need to remember that there are 2 parts in a recursive query. One is the anchor part. Second one is the recursive part. And the recursive part reference from the CTE itself. Okay. Now, how it works is the anchor query runs once and provides the initial data for the CTE. So this anchor query will be running once, then provide the initial data for the CTE. Then the recursive query will repeatedly process the data returned by the previous iteration, adding new rows to the result set. Now this recursive query will stop when the termination condition in the where clause of the recursive query is satisfied. Until this where clause query is satisfied, the recursive query will be running repeatedly. So this is how it works. Now, key features of recursive CTE. So we have union all, which will combine the result of the anchor and recursive query. Now, in the CTE, we might have duplicate values. That's why we are using union all, because it will return all the rows, including the duplicate values. Second one is termination condition. The termination condition, which we are going to write in the where clause of the recursive query part, will ensure the recursion stops when the desired condition is met. Until then, it will be running repeatedly. Third one is reference itself. So as I said, there are 2 parts in recursive CTE. First one is anchor part. The second one is recursive part. So the recursive query will refer to the CTE by name and it will create a loop for the recursive query to run repeatedly. Now, let's look into the practical applications. So we'll be solving 3 questions. First one is generating a sequence of numbers. So we are going to generate a sequence of numbers between 1 and 10 using recursive CTE. We'll also look into how to generate a sequence of even numbers and odd numbers. Second, we are going to look into generate a series of dates. So we are going to generate a list of dates between 2 given dates. And also we are going to look into how to calculate factorial using recursive CTE. So let's go to SQL and check how we can do it. Okay, let's now solve the first question. So first question is generate a sequence of numbers. And the question is we need to generate a sequence of numbers from 1 to 10. So first we need to write the recursive clause. So let me show you the syntax once again. The syntax is with recursive. Then we need to provide the CTE name, columns. It's optional. Then we need to write as. Then the first anchor query we need to write. Then union all. After that we need to write the recursive query with a where clause. Then from the CTE, we are going to extract the values. So let's start with this syntax. Let's start. So first we need to write with recursive. Let's name this recursive query as number. Okay. Now let's write the anchor query. Okay, let me name it as anchor query. Anchor query. So it will be understandable in a more better way. So anchor query, select one as num union all. Okay, we need to write here union all. Now we need to increment the values by one. So we are selecting one as the first value in anchor query. Now in recursive query, we'll increase it by +1 again and again in the repetitive loop. So next one is recursive part, right? So query select num plus 1. So as I explained earlier, so this recursive query will take values from this CTE, this anchor query part, right? So we name this CTE as numbers. So from we are going to write numbers where now we need to write the termination condition on which point our recursive query should stop the iteration. So where num less than 10. So this is our termination condition. Now let's get these values, select start from number. Now let's run this query. Okay, there is an error. Okay, there is a spelling mistake here. Okay, it's done. Now let's run this again. Okay, see, we got the values from 1 till 10. Now let me explain this whole query part by part. So what happening here is the with recursive clause allows the definition of a recursive common table expression. Now a recursive CTE has two parts, anchor query and recursive query. Now in this anchor query, we are providing the base case, which provides the initial value for the recursion. Now in the recursive query, that is the iterative step that builds on the result of the previous iteration and references the CTE cell. Together, the anchor query and the recursive query generates a sequence of rows by repeatedly applying the recursive logic until a termination condition is met, which is written in the where. Now this anchor query part, select one as num. This is the best case of the recursion. It produces the first row in the sequence with the value 1 in the column named num. Now at this stage, the number CTE contains is 1. Then comes the recursive query part. So the recursive query references the number itself in the CTE. So it takes the most recent value from numbers, which is 1, then adds 1 to it. This generates the next number in the sequence. Now, this iteration continues until the value of num is less than 10. The when num less than 10 clause ensures the recursion stops when the number reaches 10. Without this condition, the recursion would continue indefinitely, causing an error. So we need to make sure whatever the condition we are putting in the where clause, it meets at one time and gets stopped. Now this union all, what it does is it combines the result of the anchor query and the recursive query. And union all returns all rows, including duplicates, if any. This is necessary for generating sequential numbers. The recursive query is repeatedly applied to the output of the previous iteration until the termination condition is met. Now in the final query we wrote select star from numbers. This retrieves all rows generated by the recursive CTE. By the end of recursion, the number CTE contains a sequence of numbers from 1 to 10. This is how it's working. Okay. Now suppose you want only the even value. Suppose even values from 1 to 10. What we can do is we can modify this query a little and we'll get the output. Okay. Let's try this. Okay. Suppose generate a sequence of even numbers from 1 to 10. Okay. Now what we are going to do is let's copy this query. We'll make a slight change in the query. So let's start with 2. So 2 is the first even number. So here also we are going to write num plus 2. So 2 will be the first value. Then 2 plus 2, 4 will be the first value. Then until the number is less than 10, it will repeat. Okay. Now let's run this query. See, we got all the values, even numbers from 1 to 10. 2, 4, 6, 8, 10. In the same way, we can get the odd values as well. This is very simple. Suppose we want odd values. Let's write it odd here. So the first odd value is 1. Okay. So this num plus 2, let it remain as it is because 1 plus 2 is 3. Then 3 plus 2 will be 5. 5 plus 2 will be 7. 7 plus 2 will be 9. Like that it will work. Okay. Let's run this query. Now let's check our output. See, we got 1, 3, 5, 7, 9, and 11. This is how it works. Okay. Now let's look into the next question. So the next question is, we need to generate a series of dates between two given dates, which is 15th December 2024 and 10th January 2025. So we need to generate all the dates between 15th December 2024 till 10th January 2025 using recursive CTE. Okay. So let's start with recursive. Let's name our CTE as date underscore series. Bracket. First, we are going to write our anchor query. Let me write anchor query. So our anchor query will be select. So our given date is 15th December 2024. Right. Select this one. So now we are going to convert this into date data type. Okay. This is a string. We are going to convert it into date and name it as date underscore value. Okay, then union all. Now we are going to write our recursive query part. Recursive query. So now in recursive query, we are going to increment the date by 1. So select. So we are going to use this date value to increment. So select date value plus enter 1 from the CT date series. Let's copy this where this date value is less than this 10th January 2025. Okay. Let's make this as date data type as well. So date colon date. So this is our termination condition. Now let's query the result. Select date value date series. Okay. Now let's run this query. Okay, we are getting an error here. So the error is recursive query date series column 1 has the type date in non-recursive term, but the type timestamp without the time zone overall. Okay, so we are getting an error here because of this part. Okay, so here we have directly mentioned it as a date data type in the where clause as well. However, here it is calculating as a time zone data type. So we need to convert this into date as well. So let's do that. Okay, select. Let's put all of this. Sorry, this part. Let's put all of this inside a bracket and convert this into date data type. Okay. Now let's run this. This should work. Okay, it's working. So we got a series of date. Okay, there are too many values. Okay, see from 15th December, we got 16, 17, 18, 19 till 10th January 2025. So this is how you can generate a sequence of date using recursive query. You can also use order by clause here. So order by date value. So this is in ascending order. Let's make it descending. Let's run this query. Okay, we got this in descending order. The output from 10th January it's starting and ending at 15th December. So this is how we can do that. Now, how this is working is, so this is the recursive clause part. So where we are naming a city as date series. In the anchor query, we are selecting the date, first date from which our iteration should start. So this is 15th December and we are converting this into date data type and naming it as date underscore value. So in the recursive query part, we are increasing this date value by 1 day. So the interval is 1 day. Then we are converting this into date data type as well. Now in the where clause, we gave the condition that this date value should be less than 10th January 2025. Until then, this condition should met and the recursive query should iterate. Then we use the select clause. So date value from the city date series. Then we ordered it by descending order. We can order it by ascending. Now, if you want, you can get the alternate days as well. Just increase it by 2. You'll get alternate days. So suppose we want the alternate days between 15th December 2024 till 10th January. So we change the interval to 2 days. Now let's run this query. We got the alternate days, 10th January, 8th January, 6th January, like that. So we can do like that as well. So we can do many modifications based on our need. However, this is the query to get the list of dates between two given. Okay. Now let's move to the next question. So the third question is compute the factorial of a number 5 using a recursive CTE. Okay, let's write this. So first we need to write the recursive clause. Recursive, let's name it as factorial. So first we are going to write our anchor query. Select 1 as n, 1 as factorial. Okay, then union all. Then we are going to write our recursive query. Select n plus 1, factorial. So we are going to multiply it with n plus 1. Okay, there might be an issue because we are naming it as 1 as factorial as well, c as factorial as well. So let's change it to factorial underscore c. So it will be better understandable. So we want the city, factorial city, where the condition is n less than 5 because we want the factorial of a number 5. Okay, now select n comma factorial from factorial underscore city. Now let's run this query. Now we got the factorial of 5 is 120. Okay, so how factorial is calculated? Suppose the factorial of 5 will be 5 into 4 into 3 into 2 into 1, right? So 5 into 4 into 3 into 2 into 1 will be 120, or otherwise 1 into 2 into 3 into 4 to 5. So here we are getting, see, factorial of 1 is 1, factorial of 2 is 2, factorial of 3 is 6 because 3 into 2 into 1 it's 6. Factorial of 4 is 24, 4 into 3 into 2 into 1. Then factorial of 5 is 120. Okay. Now let's understand this query. So this anchor query, it provides the initial value. So the base for the recursion, which starts with 1 for n, then 1 for factorial as well. Okay. Now in the recursive query part, it references the factorial CTE to calculate the factorial for the next value of n iterative. Now here we are increasing the value of n by plus 1. Also we are multiplying the number, factorial number, with n plus 1 value to compute the factorial of the next n. Now this where clause, it stops whenever the value of n reaches 5. Now this anchor query, select 1 as n and 1 as factorial. This is the best case. It initializes the factorial computation for n equal to 1, the first number in the sequence, and factorial equal to 1 for the factorial of 1 is 1. As we know, the factorial of 1 is 1. After this, in the recursive query, what happens is we are writing select n plus 1 and factorial into n plus 1 from the factorial city. So n plus 1, it increments n by 1 to compute the factorial for the next number. And factorial into n plus 1, it multiplies the current factorial value by n plus 1 to compute the factorial for the next number. And the recursion stops when n equal to 5 because of the where clause where we have written n less than 5. So this iteratively calculates the factorial for each n until n is equal to 5. Now union all, it combines the results of the anchor query and recursive query, and it retains all rows, allowing each step of the recursion to contribute to the result set. Now in this final query, we are retrieving all rows generated by the recursive CTE, and the final output shows the factorial for each value of n from 1 to 5. Okay, this is how it's working. I hope you got the ideas from the practical applications of all these 3 questions, how to solve a question using recursive CTE. Now let's look into the use cases. So we use recursive CTE to get the hierarchical data. It navigates like a tree structure in the organizational charts or file systems. For example, finding all the employees under a specific manager, then generating sequence of data like creating series of date, number, or other sequences. Then it's also used in transitive closure where we find the connected components in a graph. Then it also used for path finding, like finding the shortest path. Now advantages of recursive CTE. First one is it's readable and declarative. So recursive CTE, it provides a structured and easy to read and understand way of handling recursion in SQL. And it has built-in termination. So SQL automatically stops recursion after a certain depth if there is no termination condition is defined in where clause. The whatever condition we have defined, if it is not met, so the SQL automatically stop recursion so that it can avoid infinite loops. So like in PostgreSQL, the default limit is 100, which we can also configure according to our needs. Thank you. This is all for today. Thank you for watching. We are going to look into a few more questions which we can solve using recursive CTE in the next video. If you have any other SQL question which you want to solve us, you can also put it in the comment section. We'll look into it and we'll try to make a video on it. Thank you for watching. We'll see you in the next video.